So now we are going to take a look, my old project. Basically, we follow this design pattern specifically, right? We have it is a web application. We have our UI application deployed into the S3 bucket. It is a static application, and then we have our backend that is Spring Boot application that is we deployed into the Fargate ECS container Fargate, and our database. We created it is a Dynamo DB. Some portion, some of them, we kept it into the Aurora DB. Okay, and this is the front layer. Basically, here only the user will come to the cloud front URL. We will give it to them, and when once the user click on the any web pages URL, what will happen is in the cloud front there is a behavior and then origin, right? First it will check the behavior. Is this say for example my is my application, right? Is this my? Yes, it is my. If it is a my, then what will happen is the pattern will goes to S3 bucket. Before go to the S3 bucket, what I need to do is because I need to change some of the URLs, right? Because for routing we are adding some additional for routing we are adding that no slash my. Actually we don't need that application will not know what is my, right? So we need to remove that, so that has been removed by this removed by the edge lambda. We introduce so many application with single host actually, and we added Octa. We will log in by one time and access by all the applications. I mean, we will log in, I mean, we will allow the user to log in by once and then access any applications, because we created once the user is login, we created a dashboard in which the user will go and pick the what is the right application they want. They will go back actually. Once the user sign out by one application, everything will be sign out in such a way that we designed it. Okay, so that's why we are about to write this lambda. If we don't have that requirement, we know we can eliminate this actually. So this will override my URL. It will take in a fraction of second, and then it will go to my S3 bucket and then pick the right page, and then it will render into the UI actually. In the UI, we are integrating our backend actually. So right, in the Angular, we have a three profiles: dev, stage, and then prod. In the prod, we will have sorry, in the each environment has its own backend. So we deployed the application into the Fargate, right? So how we will reach is we will go via the API gateway actually. So if anything starts with API, my slash API, it means that it is a my application, and then in that we have a backend. It will come here actually. In the API gateway, we are authorizing by Octa for auth methods. Public methods we no need to protect it, but we need to protect. I mean, we need to do certain things. Say for example, if the request is coming from the right origin or not, right? X origin verify, we need to check that. And what we need to do is in the CloudFront itself, we are adding another WAF rule. Basically, we are here in the API gateway. I said that the X origin verify will do that origin verification. In the CloudFront, what will happen is it will do the check, rate limits actually. Does this is request is coming from the right origin, and is that exceeding the rate limit? Throw it away in such a way that we are we are protecting our application. And once it is coming to here, it needs to go to the Fargate actually. After go to the Fargate, it is application control, right? Application will has different path actually. In the each controller has its own path. So for the Scala application, especially for the play framework, right? We are also defining in a separate file, but whereas in the here we used a Spring Boot. In each controller itself, we will have a what shall I say, the path defined actually. So and then individual controller methods will be there. that has a request mapping, and then either it could be the get, or it could be the post, or it could be the delete or put method, depending upon the the HTTP method. We are defining that, and then that a controller will talk to services will talk to my repository, or else and then in the repository we will specify use that entity, because the whatever the table structure we have, Postgres SQL, the same table structure we need to put it into the entity, and then we will write JPA, we will write JPA factory methods, and predefined methods, right, for CRUD operations. If I wanted to customize it, I can use the HQL, through which we can able to join the queries, whatever we wanted to customize, we can do that. And then the response will come to the services will send back to the controller will be sending back to my API gateway will sending back to the CloudFront. Actually, CloudFront will sending back to my UI. So in such a way that we built it. And in our applications, right, we have so many lambdas. Say for example, see here, what we are doing is, this one we will take this lambda. What we are doing is, we wanted to protect all our we are not adding any Spring security for our web application, because we don't want to control, we don't want to give the security in the application level. Instead, we wanted to give everything on the API gateway level. Okay, so what we did is, we for that specific path, we added Okta authorizer, I mean Lambda authorizer. That Lambda authorizer, we use Okta authorizer. That Okta authorizer, we will talk to Okta, and then we will get the there are some templates there that we need to know, right? We used a Node.js template, where we will create separate custom policies, and then based on the the response, we will get the policies, and then that policies we will send it back. And then in the API gateway, if it is unauthorized user, say for example, I have to the my UI application, right, we integrated with Okta actually. So it generates the token, it gives the token, and then the token will be, whenever I am sending the request to my backend, that header will have a token. The token will come to this place, and then it will check whether the request is coming from the already we checked the two layers. One is the X origin verify, and we checked that rate limit, and then finally we are checking that hey, is this the right token that is provided by the user, or that the guy have a right session or not, right? Everything will be checking by this. And then if it is not authorized, then it is sending back to the not authorized. If it is if there is any exception, once after that, it will go to the target, right? If there is any exception, or if there is no records, whatever the respective responses we need to show, we will send it back to the API gateway, and then that API gateway will return back the things to the CloudFront. Actually, that's how we are doing it. And we written some of the other lambdas as well. Basically, some few lambdas we written the trigger as a API gateway. Few lambdas, right, we added a scheduler, basically. A scheduler in that sense, right, event object. Actually, if the event event bridge, basically. The event bridge is, it is a scheduler. So based on the time, right, on the, say for example, and every month we run this one. So in that case, what will happen is, my lambda will talk to my DB, and then it will process it actually. So right, that we it is a small piece of logic we need to write it. In that case, we can go with lambda actually. So that's how we developed a lambda. And and one more thing, I mean, that's how my application, right, forget it needs to talk to outside of the world, to Okta. So we created outbound proxy API gateway. It is a private API gateway, in which private API gateway, it will not be available for the user access. It is only for mission to mission communication. But here, AWS to outside of the world communication, right? Through the VPC, it will go out and then talk to the Okta, and then it will do. Because in the Fargate, we written endpoints, right, that needs to talk to Okta actually. So in Okta only our original data are available, user data is available. So it will go and fetch the data, and then there are various policies. Say for example, if the user added any MFA, multi-factor authentication, those details will be there in the Okta itself. We need to bring that, and we will write a lot of business logic here, because we have a profile settings in which the MFA will can be either we can edit it, we can modify it. Those things, in the profile setting page itself, we need to do it, right? So by the time they will talk to my backend, the backend will talk to my Okta actually, in such a way that we designed it. And by Fargate, right, it needs to talk to downstream system as well. Say for example, if I wanted to make communication from one application to the another application, I need to talk to, right? So for that also, my Fargate need to talk to another AWS account. In that case, right, we will create an assume role with trust policies, and then we will create a token, and that token will be given to that Fargate. We have AWS SDK, right? Using that AWS SDK, we are able to successfully talk to other API gateways that are defined in another AWS account, and that's how we will able to talk mission to mission communication as well. If it is a user based communication, we will go with Okta. If it is a mission to mission communication, we will go with an IAM resource, IAM policies actually. um, that's how we designed it. We used Aurora database and then DynamoDB. Aurora database, right, it is a Postgres SQL, and then DynamoDB, it is a document based database. It's unstructured fully. So depending upon the use cases, right? Here our use case is DynamoDB. We wanted to keep all our users key informations into the DynamoDB, whereas for the Aurora, right, it is for some user defined, say for example, on the on the page itself, if what application frequently the user is, what kind of what kind of features they are consuming more, right? We are tracking them everything, and then we are putting into the all our the tracking, we are putting it into the controller itself. We write an advisor. That advisor, we hook it to the records actually. That's all. So yeah, it's based on the scenarios actually. So likewise, right, we have another application called as API portal. So here you can see that same design pattern. What we are trying is, we are coming to the cloud front. It will go to the UI for this path. Can you see here, developer it is. Earlier it is my, right, it is a developer now. And then here it is coming to my API gateway. Here we are overriding the URLs, and then we are using the same Okta authorizer lambda, and then we are writing that WAF rules, and then we are trying to talk to my Fargate actually. Here, we create a lot of lambdas. This is another system, EWS, right? It needs to talk to my lambda. It is a custom authorizer. We write our own custom authorizer because our shipping channel, right? The business idea is we need to expose a lot of RESTful services. Sorry, rather a lot of services related to shipping, and all the e-commerce portal they will use it actually. To use it, they need to create the keys actually. We are providing two services. One is sandbox, the another one is production. Sandbox for testing purposes, they will use it, and then they will check how it is working. And then once they wanted to move to production, they need to come to the purolator support agent. They will create a key, or else self-serve portal it is. Just they will come here and then log in, and then they will create the keys, and then they will go to their web services here, and then they will call the web services, and then they will attach this username and then password. Suppose if it is a platform, right, they will add three values: username, password, and then no token. All these three they will add it, then they can consume our services. This is a biggest, I mean, there are many e-commerce portal, they are using it. The services like she create the shipment, they create the pickup, and then create the a locator, and then create the pickup, and then which location we need to come and pick the parcels, right? All this, it's related to the parcel informations. So that's how we created it actually. Technically, we used the Fargate container. Do you know how we are deploying it? We are using that as CI/CD pipeline. How we are whenever the developer commits the project, first, if we are committing into the developer branch, then it will deploy into the dev 01 I mean dev environment. If we are no creating any the release branch from the developer branch, then we are deploying into the staging environment. It is a prod, and then whenever we are merging from the release to the master, we are deploying it to the deploying into the production actually. So that's how we developed it. In the right, the this is Java application, basic Java application. And then in the CI/CD pipeline, basically, the GitHub action, right? It will run everything on the Linux machine. So what we will do is we will get the pull the repository, and then put it into the local. We will go to the specific location, and then we will run the commands, right? The same way we will use we used a Python, and then we run the build, and then we will push them into the we will do the Docker build, like yeah, Docker build, and then tag, and then push, and then it will go back to the Docker. From the Docker, we will try to push it to the AWS actually. So uh, then it will push it to the AWS. AWS code pipeline. From the AWS code pipeline, it will push into the ECR. From the ECR, it will go to the container actually. This is how we developed it actually. So for front end application, it is quite simple. Just a drag and drop will work, right? So, but in case of CI/CD pipeline, whenever we build, all the dependencies will be downloaded into the GitHub Linux machine, and then it will build it. Once it is create the dist folder, inside that the tar I mean that the zip file will be there. Just we will use AWS CLI command, and then it will push into the this one. So basically, we automated that way. And we used Maven for build tool. Maven, right? 3.9 we used for building the application. In the palm file itself, we have defining that a lot of dependencies. If we are using the JPA, we will use the JPA. And then it's a Spring application, right? Spring starter web, a lot of other dependencies that are all required. And we all the request and then response, right? We created the custom Pojo objects. Those Pojo objects, right, we kept it in a separate project. So every developer, right, they will keep on adding based on the services. Those objects will be added as a dependency, and then that will also build it actually. So that's how the Maven will work. And then how we if there is any issues happen, what I will do is we will go to the AWS CloudWatch log, and then we will check that. We use CloudWatch insights to query that specific things. And we have CloudWatch metrics as well. So in the metrics, we created a simple dashboard. What can you list out 4 access issues, or can you list out 5 access issues? Those kind of dashboard to be created. It is quite simple to create it through the metrics. Just we need to map it, and then we will get it. And in the AWS, what else we did is uh, yeah. In this application, can you see here? We are talking to outside of the world, as well as we are talking to outside of other AWS accounts. Actually, that also we are doing it. That's the that I wanted to show here. Here through the AWS SDK, right? We just send that what is the path, and then what is the credential, username, and then password, and then what is the region, and then what is the assume role, ARN, everything. When we pass it, we can able to communicate it to individual API gateways actually. So basically, those applications, I mean, those are all a separate account in which we will deploy our application, and we are referencing it, and then we are accessing it actually through the AWS Java code actually. Yeah. Uh, and then that's all here. And finally, just I listed it, what are all the services we have. Basically, we used For EWS, we developed step functions, right? This one, I worked on all the lambdas. A few, designed by my other colleagues. They designed it. So yeah. So I worked on a couple of projects. That's all actually. This is how I have a capable, and I used Angular as well. Angular, last 6 years I used most of them Angular 2, specifically Angular version 14. Earlier we used Angular JS as well. That is outdated, and then we don't have a, it's a end of life, right? End of life. So we will not get any support. So we stopped to work on that Angular JS. We migrated them to Angular 2. It taken a lot of time actually, 6 months, from Angular to Angular JS. Sorry, Angular JS to Angular 2. Then now our application is stable, and whenever we are seeing that upgrade, we used to update the component, and we never use any npm old libraries, because that was developed by something else, right? So as much as possible we will create our own component, and then we will keep it in the shared library, and from the library we will use it actually. So purelator has its own design pad. They have a design guidelines. Whatever the design guidelines they given, say for example, what is the size, what is the color, what is the what is the color, the image we have to use, everything will be there in the one place. If we are changing, if we are changing in one place, everywhere it will be changed actually, right? So I mean, for that we anyway we need a deployment, because when we build, it is taken the copy and then it is building it, right? It is not like, if we change, everywhere it will change. It's not like that. Yeah, it is kind of. That's how we developed. Even I worked in the React applications. React application we developed it. We are React components, but not much. A few components I think I debugged it, and then I fixed a few issues. So yes, so even React also I had a I got an opportunity to edit it. So I believe that's all from my side. If any questions.